In this next lesson, we are going to extend our knowledge of multiplying binomials by binomials to multiplying any type of polynomial by any other type of polynomial. In this first activity, I would like you to take a couple minutes, and I'd like you to try and use the rectangle diagram strategy that we learned in the previous lesson to multiply these trinomials by trinomials. Now I'm going to do both of them below, and we'll start with the first one there. Now that there are 3 terms in each polynomial, we need to have 3 rows and 3 columns. So I have A plus B plus 2 and C plus D plus 3. So now I have 9 different rectangles to fill in. A times C is just AC. B times C, BC. 2 times C, 2C. A times D, AD. Now, you could write it DA, but we generally write in alphabetical order. It makes it easier to find if there are any like terms. So here we have D times B, so I'll write it in alphabetical order, BD. 2 times D is 2D. 3 times A will be 3A. 3 times B will be 3B. And 3 times 2 will be 6. Now, if we were to look through here, there are no like terms. So we are going to have 9 parts to our answer. So I'm going to have AC plus BC plus 2C plus AD plus BD plus 2D plus 3A plus 3B plus 6. Definitely not a nice answer, but that is what happens when we expanded those 2 trinomials. We ended up with 9 terms. Let's look at the second one. Again, there are 3 terms in each. This time we have A, we have a minus B and a 2, we have a C, a D, and a minus 3. Same types of terms, just with some different signs. So I'm guessing we are still going to have 9 distinct terms at the end, but some will be negative. C times A is AC. C times negative B will be negative BC. 2 times C, 2C. A times D, AD. Negative B times D is negative BD. And 2D. Negative 3 times A is negative 3A. Negative 3 times negative B would be 3B. And negative 3 times 2 will be negative 6. So we can add these all up. AC minus BC plus 2C plus AD minus BD plus 2D minus 3A plus 3B minus 6. So as you can see, the rectangle model actually organizes it very nicely for you. You will not forget to do one of your multiplications. You will definitely hit every one because you have to fill in every rectangle. The distributive property can also be used to perform any polynomial multiplication. Each term of one polynomial must be multiplied by each term of the other polynomial. Although the distributive property will take up less space on your piece of paper, and it might be quicker to do, it is easier to forget a multiplication along the way. But it is one that a lot of you will end up using. So we start here. We have 2 terms. So each of those terms need to be distributed into the second bracket. We'll start with the 2h. 2h times h squared will be 2h cubed. 2h times 3h will be 6h squared. 2h times negative 4 will be negative 8h. Now we take the 5. and we multiply it to every term. So 5 times h squared will be 5h squared. 5 times 3h will be 15h. And 5 times negative 4 will be negative 20. Look for like terms. We have h squareds. We have h's. Now in binomial multiplication, I said we generally write the squared part first. Really, when you're doing polynomial multiplication, we generally write the largest exponent value first, the largest degree. So I'm going to start with my 2h cubed. Then I'm going to do my h squareds, and 6 plus 5 is 11, so we have 11h squareds. Negative 8 plus 15 is 7h, and then we have minus 20. And that is expanded and simplified. Let's look at this next one, a trinomial by a trinomial. Think back to the activity we did at the start where you had a trinomial by trinomial. You should have had 9 terms that were multiplied. So our first row here should include 9 multiplication parts. Negative 3f squared times 4f squared is negative 12f squared. Negative 3f squared times negative f is positive 3f cubed. Sorry, this first one should have been f to the 4th. 3f squared times negative 6 will be positive 18f squared. Take the second term. 3f times 4f squared will be 12f cubed. 3f times negative f will be negative 3f squared. And 3f times negative 6 will be negative 18f. Negative 2 times 4f squared will be negative 8f squared. Negative 2 times negative f will be positive 2f. And negative 2 times negative 6 will be positive 12. Double check. Count that you have 9 terms there. We do. There are 3 of each color, so that are 9 terms. Now we need to look for like terms. We have some f cubed. We have a bunch of f squared, and we have some f's. Working largest degree or largest exponent down, we start with our f to the 4th. We have negative 12f to the 4th. 3f cubed plus 12f cubed is 15f cubed. 18f squared minus 3f squared minus 8f squared will give us 7f squared. Negative 18f plus 2f will be negative 16f plus our constant of 12. And that is expanded and simplified. Sometimes we have 2 variables. The process is still the same. An exponent of 2 means this bracket occurs twice. And now we have just a binomial times a binomial multiplication. You can use your rectangle model or you can use your distributive property. It's up to you. We use the distributive property. 2r times 2r will be 4r squared. 2r times 5t will be 10rt. Remember, we write them in alphabetical order so it's easier to find like terms. 5t times 2r. 10. Now some of you might write it as tr, which is perfectly fine. But if you write it in alphabetical order, we're going to recognize we have like terms. And then 5t times 5t is 25t squared. Now because we have 2 squared values, take the one that comes alphabetically first and leave it at the start. So we'll have 4r squared plus 20rt plus 25t squared. All right, the last example. It's a binomial multiplied by a trinomial. You can use the distributive property or you can use the rectangle diagram. Since we have not done any rectangle diagrams with a binomial times a trinomial, that is what I will use. So I'm going to put my binomial along the top, and I'll put my trinomial down the side. And it really doesn't matter which way you do that. Notice we are going to have 6 parts. 2 terms times 3 terms, that's 6 parts. Back here with the trinomials, it was 3 terms times 3 terms. 3 times 3 is 9. There were 9 parts. So that's kind of a little hint to know how many you should have. So now we fill in each rectangle. We will have 12x squared minus 8xy minus 9xy, go in alphabetical order, 6y squared, 15x, and minus 10y. Some of you are going to start finding the shortcut where you can just write your final answer from here, because you will locate your common terms within the rectangle. If you still haven't figured that out, that's fine. We can write every term down and then look for the like terms. We have like terms right here. So I'm going to start. I'm going to have 12x squared minus 17xy plus 15x minus 10y plus 6y squared. And we have multiplied or expanded and simplified.